All right, Lady Ada, we are back.
I know. It was great.
What is this?
We're back, and it's time for show and tell. Thanks everybody for chilling for the last couple of weeks. It was cold, it was windy, we got cozy, and we charged our batteries.
They were making and sharing electronics, and now the sharing part begins, where we're going to show all the projects that people have been working on.
What did you work on the last couple of weeks? Maybe you did Christmas stuff. Maybe you did Hanukkah stuff. Maybe you just lazed around. Maybe you did a project that's been sitting on your desk for 10 years.
That's right.
Let's check in with some folks from the Adafruit community and see what they're up to.
That's right.
We miss them greatly. First up is Scott.
Hey, Scott. We just posted the interview, sort of interview, with you and Lamore talking about CircuitPython 2025. It was good to see you here in person. What is going on this week?
Yeah. Thanks for having me in person. It was wonderful to hang out and do a little bit of CircuitPython chatting. So this is Zephyr. Unfortunately, as is my MO, I kind of like to show things that don't work. So what we have here, this is a backtrace of it crashing. But the cool thing here, I've mentioned it. So this is CircuitPython built on top of Zephyr. And Zephyr is this big real-time operating system ecosystem. But they have this cool thing where you can just do West debug, and it builds everything and then loads it and gets me right into GDB.
Oh, nice.
So now I can just run it. You'll see that I'm getting output, but it's hanging. It's not getting like all the way to the REPL. And so I can just Control C, and you know it's halting. I'm trying to get that working.
Okay.
But what I'm doing is I'm trying to automatically come up with where the CircuitPy file system should live. So given any Zephyr board, where should it go? So if it's an NRF52840 Express, and they've said that like, hey, there's this flash connected to the chip, like we'll find the flash and we'll put CircuitPy there. That actually works for this L15 board. And when I was visiting, you gave me this RA8 board, which I'll just unplug, this big one.
Yeah, huge.
Big, huge one. And I was just looking, it doesn't have all the features in Zephyr, unfortunately, because this, wrong side. This chip is an SD-RAM chip, which is very interesting. That's something we don't have support for in CircuitPython, but Zephyr supports SD-RAM chips.
Does it just do the memory mapping for you? I mean, like...
Yes, I'm working on that.
Okay.
I think so. I think so.
Does it work yet?
It doesn't work yet, but you know, once we it should be that like it does all the initialization for us, and we don't have to worry about it, which would be really awesome. SD-RAM is not something we support in regular CircuitPython right now. And then the other thing is that there's this Octal SPI flash chip. That is also, unfortunately, not supported in Zephyr right now, because I think if it was, I would be able to automatically find it and put CircuitPy there.
I mean, I chatted with the Renaissance, and they're like, we're still working on the Zephyr. They do have a fork that might have support. They mentioned that. But I would just keep going with something that has good support for now and then double back.
Yeah. And in fact, anybody who's watching this, if you've worked with Zephyr and you know which boards are best with Zephyr, right? And like most fully supported, that would be a good tip for us to start with.
Yeah. Any Zephyristas? What's the word?
Yeah, I guess we should mention too, like this is how we ran into Scott. Scott was doing work, and he had a company, he was doing things, he was asking about like testers and everything. Eventually we hired Scott, we're working together, and now Scott runs the lead portion of CircuitPython. We are looking for people who know Zephyr so we can hang out with more people and do stuff. We were part of the Linux Foundation Zephyr thing a while ago, but I think we were just too early for what was going on. But now with Arduino moving to Zephyr and others moving to Zephyr and us going there, I think we'll see more interest. So if y'all are working with Zephyr, let us know, because we want to.
Yeah, actually, a couple people let me know that they would be interested in contracting, and I pointed them to you.
Yeah.
Since our video mentioned it.
Yeah, we are.
I've had a couple people.
We always tell people what we're on the lookout for. This is our jobs board now. For Zephyr, we were talking to some folks today, and one of the things that we mentioned is embed went away. So this is like pretty much it's probably one of the only ways to do this, right? Like,
no, there's a free RTOS, but it's like I feel like people are coalescing around this platform agnostic, non Amazon controlled.
Right.
And
for that reason. So if you could do other ones, but they're
people have used them, but there was always the downsides, or the chips weren't powerful enough to really take advantage of it. There's a lot of, you know.
And free RTOS is pretty limited. It's just the RTOS part, whereas you know what we're looking to leverage with Zephyr is like the Bluetooth stack and like initializing SD-RAM and things like that.
It's particularly like Nordic. That's sort of like we're only supporting Zephyr, so it's like, okay, well now you have to.
Right.
So and then de facto standard.
It's becoming it's becoming a de facto standard.
Yeah. Okay. So my plan is to like support the newer Nordic chips with this port rather than our existing one, for example.
Okay, cool. Well, you're doing deep dive this week. Are you going to show some Zephyr?
Oh yeah. And I have to write my CircuitPython 2025 post before then as well.
Okay.
Yeah, we posted up the interview. We have a bunch of posts. Tag your needs and wants. I guess Zephyr for CircuitPython is going to be in there because that's.
That's definitely part of mine. I was saying, like, on my deep dive last week, I did this, like, here, I pulled a random dev board that I have, let's get CircuitPython running on it. And it, like, I got all the way to the REPL, which is actually not always easy.
Yeah.
So being able to just, like,
UART
pick
or
things up
USB?
and it's all UART right now, unfortunately.
Okay. Still, you know, there's a lot you need to do to get that working.
Yeah, like timekeeping and compilers and compile flags and all that I don't need to worry about.
Yeah.
And now I'm doing the Flash, so if I can automatically find where in the Flash I should go.
Yeah.
That's been good too, so.
Okay.
Yeah, getting there.
All right, all I have to do is fix this VFS block dev C failure. It looks, Flash.
That's all you gotta do.
It looks like Flash IOctal is like, it's like, wait to the Flash, and they're like, we don't have a Flash.
Right, so I'm trying to, and CircuitPython does have a mode where it doesn't have any Flash, and it will go into like a safe mode for you. Yeah. But for some reason right now, I'm not getting all the way there.
All right.
And I should. And I was actually going to have it print out like, hey, I think this is how you want to configure your Flash. Like copy this bit into this file, and then we'll know, and we can just do it.
Okay.
All righty. Well,
that's
thank
where
you
I'm at.
so much, Scott. We'll see you on Party on Deep Dive and more.
Yeah.
And I might try to pop in after our all-company meeting that we do each week. And I have some questions about Zephyr.
Sweet.
I'm new to Zephyr, so.
Yeah, and actually, your meeting's early before us now.
Yeah, we moved them.
Yeah, so
I might be able to do it.
Plenty of time.
All right, thanks so much, Scott. All right, next up, we're gonna go to JP because he's in California, and I kind of feel like any second he's gonna be like, all right, JP, what you got going on?
Hey, thank you so much. I appreciate it. So what I've got, good, you can see both of me. What I've got going on, besides hoping that the fires don't come our way and the winds die down tonight. So far, we haven't had to evacuate, which is nice. But what I've got going on as a nice distraction is I've been working on this animatronics guide showing how to do basic animatronics on your computer using Bot.Tango, which is some free software that allows you to animate like you're used to animating if you're a CG animator. But the additional thing going on here, I've got a little two servo pan tilt rig that I put together and my little gnome guy there. The additional thing I did was hooked up a PlayStation controller and enabled live input. So you can do things like just puppeteer your rig. So here I've got just a pan tilt on my little guy here, which is fun. You can do, real-time stuff like, hey, what's going on, Phil? Oh, boy.
Yeah.
Or you can record that. So you can tell it to start recording an animation that you do, and it lays down sparse keyframes, which means you don't get like a keyframe per frame, which you can't edit like motion capture data. It, in fact, is smart enough to just lay down a sort of moderate number of them, which you can then go in and hand edit to say, oh, I didn't like the speed of that or the position of that there. So I've started to do some little animations that I'm going to put in the guide that people can use as a starting point. And I will show in more depth tomorrow, presuming that I have my workshop show tomorrow, how to do this inside of the software so that people can do their own simple animatronics.
Yeah, we've been chasing after this for like 10 years. Like, how can you do easy animatronics? We're getting closer and closer and closer.
Yeah. It's really a game changer compared to anything I've seen in the past for sort of at-home use. of this kind of stuff.
The recording and playback is a big deal, and then easily being able to, transcribe the movements. Is really hard. We saw a demo. I'm not going to go into details, but it used ChatGPT to move a thing around, and they built something in between to say oh, move it 10 degrees, do this, do that, and that was a really neat demo. We'll look into see if there's things like that, because the natural language would be kind of the other interface, like a voice, tilt your head, move up, look over there, look at me, adding some other things like that. But this is, I feel like a game controller is a really nice
It's
interface.
really fun. Yeah, it's a really neat interface for it. And you can also do things like preset poses that you would just hit a button to go to. So you don't always have to be live puppeteering it. And it has some built-in smoothing too. So it's not, you can see it doesn't just jerk really quickly, which is nice. You usually don't.
You could tell one gnome to finish him, and it'll pull the other gnome's head off and go with him. And,
Gnomosity.
Yeah. Good. All right. Well, stay safe, and if all things continue to avoid your area, we'll see you on JP's workshop this week. We're going to play a little bit of the video that you posted up too.
Super. Thank you so much, guys.
Thank you so much, JP.
Stay not on fire.
Stay not on fire.
Stay not on fire.
Just stay non-flammable.
Yeah. All right. Jepler, what you got going on this week?
Hello. So I've got a couple things to talk about, but I'll start with the Metro RP2350b, and I've got a USB keyboard hooked up to it. And so with that set up, you can go back to my screen share.
Okay.
And if I type on it, nothing. Oops, that's not the right screen at all. Give me a second, and I'll get the right screen. But anyway, the long story short is that USB host is working now.
Yay.
And previously, it wasn't working because this is the board with 48 GPIOs on the chip, and you use some of those IOs above number 32 to be the USB. And it turns out that didn't quite work. So I've been looking at that. So let's try the screen share again.
Okay.
So this Go KBD module just enables the USB, because if I type now, nothing happens. If I hit enter, it imports that. And now the USB keyboard is attached and typing into the REPL. So that was like my first indication that the code I was working on was going in the right direction.
Great.
So this is in an open pull request, and the changes would apply to other RP2350b boards. Like there's one from Pimoroni that I know of. It's like one of those little rectangles, and I know there are other 2350b projects out there. So we're going to enable using all of the pins with PIO, with some caveats, because you're limited to which bank of 32 you can use at a time.
So you can't
we'll enable you to do more stuff. So I could get into the nitty gritty, but there are 3 PIOs, and each PIO can be independently set to use the high pins, so 16 to 47, or the low pins 0 through 31. So it's a little complicated, and you might run into some resource limitations that you wouldn't otherwise. But I2S audio out is working. Rotary encoder is working, NeoPixel is working, and USB is working. So it's a pretty solid set of stuff that is going to be enabled soon.
Okay.
So really excited about that.
All right.
And I do have a couple other things I want to talk about real quick. So I've been working on creating 3D filament. Oh, where's my little piece of plastic? See, this is terrible. People have had this idea of you could print 3D printed filament on your 3D printer, and one of the things you can do with that is print 2 different colors, and then when you print, this is a very small vase mode print, but it changes the color just within that span. I've been playing with this. This was kind of my winter project, and it works, but it's really fiddly because the attachment area of the filament to the bed is really small, and like any little ratty bits, which I can feel. There's one right here, at each join. Those can bind up inside the printer the second time you're printing it and cause your print to fail. But I mean, this is an owl because I love owls. But when I was looking at this, I'm like, I should print a bee. This would be perfect for a bee.
Yes.
So this is like some terrible Python scripts that generate G code, and I'll post some up. I'll post something up about this on Mastodon, or you can go back. I was posting on it last week, but that's something that I've been up to outside of CircuitPython world, but still in Python and still in making stuff.
Yay!
Very cool.
And
I've got all these other things to do after I'm done with that.
I know how it goes with some projects sometimes. Are you going to are you going to post up the files of your 3D print? Or
right now, I'm not going to. I feel like it's just not reliable enough that I would want to subject anybody else to it. But I think the idea is really cool. This is not my original idea. I saw this on a Thingiverse idea years ago, or Thingiverse, thing years ago, although they were concentrating on making a dual color filament with one color below and one color above. So you get that neat color effect. And you just buy reels of plastic like that now that come with the two colors built in. But I think that quickly changing colors is neat without needing a changer actually on your printer.
Yeah.
But this is far from anything I would tell somebody you should do this, because I can make a meter at a time and a third of it will feed through before I jam. So it's not ready for prime time.
Yeah. That's cool. All right. Thank you so much.
All right. See you around. Thank you.
Yeah.
Thank you, Jepler.
All right. Next up, we are going to go to Liz. Liz is going to tell us what time it is. What time is it, Liz?
Hey. Yeah. So I was working this week on documenting the Newxie displays, which I've had 4 of these hooked up to a Raspberry Pi. And right now they're running Python script that has just a counter from 0 to 9,999. Because I just wanted to show how to that each display was updating. But a more practical example that I also included in the guide, which is live now, if folks are interested, I'll start it up, is a clock. I think a lot of people want to make Newxie clocks with this. So here's the base clock code, and then people can add the graphics that they want. I'm also going to hopefully work on a Newxie clock project. There'll be a Learn guide. And this guide's live now on Learn. And
Okay.
What's neat is everyone can make their own clock with their own graphics and just drag and drop graphics.
Yes, exactly.
That is the hard part with any DIY clocks with screens, is like you're kind of stuck with very complicated ways to get graphics on there. But
and I had never used more than one SPI display at once, so trying to figure out the wiring was a little tricky, but now that's all documented, so hopefully folks can just go there, follow the fritzing, and be good to go.
Yeah.
All right. You can tell this is live because we have the time.
That's the time.
There you go. Yeah.
Now we know.
All right. Well, speaking of clocks, well, thank you so much, Liz. Speaking of
No
clocks,
problem.
I think Tim has kind of a nod to the past and more with clocks here.
Hello. Yep.
Yes.
I've been working on a display IO based analog clock face and setting it up so that it can also be easily customizable, just like you were talking about. And the first sort of fancy one that I have made here is a throwback. Happy Public Domain Day to folks who celebrate that. Steamboat Willie entered the public domain. So I've taken a snippet of Willie out of the original video and carved up the arms a little bit from some different frames in the video and stuck together this analog clock example, which is still relatively basic, but it does allow you to get your clock in there and set the minutes and seconds and not have to worry about the actual angles and everything yourself. You can just put in the time and it will update the arms for you. So right now I have it set up to just show the actual time, although it is set to Eastern time zone instead of my time zone. And the next project that will be in the works is like alarm clock style. So it will show you the time, but it will also play a little jingle once your alarm clock is ready to go off.
I can play the Steamboat Willie song.
Yeah.
Yes. Yeah.
All public domain stuff. Disney lawyers, AI watching us thing.
Yeah, definitely. And then I just wanted to show it's super simple to swap it around as well.
Ooh,
it does.
I like that. I like that.
On
Between,
you.
yeah.
Cyber.
Yeah. I like Cyber Mickey, where it's just like,
Yeah.
zip, zip, zip.
But it's super easy the way that I have set up the clock face here to swap it over, although it looks like it may be failing the NTP. Maybe we can cancel the NTP real fast.
We're gonna live
wrong way there.
I'm gonna live code this. Drip, 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 drip.
There we go. Yeah, I was swapping around to some different NTP servers earlier, actually, and I noticed that
we have
going on as well.
There's an Adafruit pool.
Yeah. So yeah, this one is just super basic. This was actually the one that I made first in order to get the rotations and everything working and being able to render bitmaps. But it does show that it will be super duper simple to make whatever custom clock you want, whether it's colors or fancy hands or fancy numbers or anything like that. It'll be super easy to just declare what you want and then put it on the display.
Nice.
This is neat. And then for the folks that we're going to do a bigger post and think about, using public domain things and this clock and everything, we're going to check with our trademark and copyright lawyers, because it is weird to be able to do things with Mickey Mouse. It's just unusual. It's the first time in our lives. But think of all the cool characters you could build and do. You can make your own characters. We have Adabot and all that stuff. Oh, this is like a Matrix clock. This is really neat. And then you can play whatever song you want or music. And then with Circuit Python, you can use any display like e-ink and more as we do this. So this will be a fun project, and you can use square and just have a circle. You don't have to use a circle display.
But this does look great.
But this looks awesome. All right.
Okay.
Good job, Tim. We will see you later,
Tim.
and we'll keep everyone posted on how to make this as we continue to cook this up and more.
Cook.
See ya.
All right.
Okay. Thank you.
And next up is Andrew. Hello, Andrew. What you got going on? Oh, I'm going to add.
Hi there. I just wanted to show off one of my projects. It's I'm taking some of the code from the nature of code, simulating natural systems with JavaScript by Daniel Schiffman. I've ported those to CircuitPython and Display.io. I got first 4 projects going. This one is a random walker. So most of the code is it's just the boilerplate setup for the 2 panels. So I've got 2 64x32 on the Matrix M4. And I've created this class. I just basically ported from JavaScript. And I can just show a couple different ones if I save these off. It's code pi. Let's see if I.
Neat. And it'll jump over to the other screen when it gets close to it.
I hope so. Oh,
where'd it go?
Why isn't it playing?
Hey, little walker, where'd you go?
Oh, I made a little.
It went for a walk.
There we go.
Woo!
Oh, bounty.
There we go.
Oh, this is
cool. That's using vectors, and that's one of my requests for CircuitPython 2025 was some really neat stuff inside of this P5.js, specifically with vectors.
Ooh, that's a good suggestion.
So I'll save this one. This is another project. This is oscillation.
Oh, nice.
Oh, nice.
So this is actually using a bunch of circles, and they're just going up and down in a sine.
Right.
Yeah.
So I create this range of 127 little circles. It's kind of fun. And then the one in my write-up I did was the particles, which I like this one a lot. It's, let's see, CircuitPy, save.
Each way to teach kids physics too, because going up and down is gravity, but it's just stretched out.
Yeah,
this is nice.
So this is little particles that are being spawned along the top of the display here, and they have a random vector and a random kind of velocity, and then
then they fall,
and they're affected by gravity. So these little classes and stuff were fun to set up, and it's if anyone has seen the coding train, it's a really cool YouTube video. So those are all written in processing now, processing JS. So I really recommend. This is all open source online, natureofcode.com. The whole thing is free, so you can go check it out and port it over to CircuitPython.
Yeah. For folks who are interested in like the history of Arduino and wiring and all this, it comes from the seed grew the mighty oaks out there. This is where a lot of things will seem familiar. If you look at processing. This is really neat. This looks like all the drones in New Jersey right now.
It's fun. I've let it run for a long time, and there's no crashing. There's about 60 particles, and then they're removed. So there's no memory loss. This is run for hours. Like I said, on the M4, which is kind of underpowered nowadays. So
this is great. Super great.
Fun.
That's great.
Thank you so much, Andrew. And if you post anything about these, email me or the team and let us know, and we'll get the word out. And that's a good book recommendation. We wanted to do a Adafruit like book club because it was like there was book talk. It was really popular. We were going to call it Book Fruit. If I could get that going, it'll be like, oh, here's a programming book that someone suggested from the community. This book obviously would be on it. This is like one of the ones when I know when it was announced, I'm like, oh man, this is a really good idea. And I try to watch Coding Train once in a while because it's like gives us ideas. It's one of the few shows that was consistently putting out something every single week or so. We do a show and we're always looking for other shows out there too. So
yeah, he's really animated. He's really fun to watch too.
Yeah, it's like a kid's show, but not for kids. Yeah, it could be for kids. Yeah, Coding Train. All right. Well, thank you so much, Andrew.
Thank you.
Right, thank you. Awesome. What a great show and tell.
Right.
Kick off the year.
Our show for the week this week. Thank you so much, everybody. We will see everybody next week. Don't forget, every Wednesday, 7:30 p.m. Eastern Time, we do show and tell. Been doing this for over 15 years now. We'll see everybody next week. Ask an Engineer starts in just a few minutes.
Bye, everybody.
Bye-bye.